Hi, so good morning. Welcome. So last time, ang diniscuss natin is yung mga different types of sensors gaya ng temperature, level, pressure, flow, at saka yung speed measuring devices. Ngayon, ang pag-uusapan natin ngayon, yung tinatawag nating Introduction to Process Control. Basically, discuss natin yung different control system gaya ng tinatawag nating on-off. We have the proportional action, sequential action, at saka yung tinatawag nating proportional, integral, derivative, leading to yung commonly na naririnig natin na PID system, the proportional, integral, at saka derivative. That is why, in the middle part of this lecture, titingnan natin how this type of system, yung PID system natin, is being incorporated sa industrial plant or sa mga barko. Okay? And then at the last part of this lecture, I will give some question and answer na possibly lalabas sa inyong quizzes at saka exam. Okay? So let's get started. Okay, so commonly, yung modes of control natin, yung basic classification niya according to a few books gaya ni William Dunn at saka kay Elstan Fernandez, they classify this one into first, we have the on-off control, okay? And then we have the sequential control, the proportional control which includes yung tinatawag nating proportional action, integral action, at saka derivative action. Basically, all of these three here, yung tatlong actions na yan are being combined gaya ng meron tayong tinatawag na PI, PD, at saka yung PID system. So, isa-isahin natin yan. Okay, yung on-off action, also known as the two-step position control. Two-step position control kasi dalawang states lang, either on or off, logic 1 or logic 0. And this is the most basic control mode. Okay? And then, so the final control element is either a fully open or fully closed. So hindi siya pwede na intermediate or nasa gitna. Okay? So the same ito dun sa mga switches natin sa bahay, di ba? So no matter how we put it in the middle, hindi talaga yan gagana. Dalawang state lang yan. Either on yung switch mo or i-off yung switch mo. Hindi gaya nung sa mga gripo natin, di ba? Yung sa gripo natin, pwede natin silang ilagay dun sa gitna. So that is the intermediate state. So in this particular case here, yung final control element natin, dalawang states lang. Either on at saka off. So para mas intindihan natin yung concept na ito, let's try to take a look at this example here. Okay, yung example na ito, basically, ito nakuha ko to sa libro ni Elstan Fernandez at saka kay Majumder. Okay, this one is applied especially on the marine engineering side. Kasi yung fuel system natin, yung fuel oil natin, in this colored here, yung nasa brown, yung fuel oil system natin, we have to painitin natin yung fuel natin. And this particular case here, kailangan natin painitin to 60 degrees centigrade, di ba? Kailangan natin painitin para yung viscosity natin, para ma-adjust natin yung viscosity. So, other than that, but basically, yung goal ng system na ito is, kailangan nating painitin yung fuel natin indicated dito sa brown box. And then, paano ba natin to painitin? Painitin natin to using steam. So, in this particular case here, steam yung nakikita natin. So, yung papasok dito na steam, dyan. And then, yung pasok at saka yung the open and close of this valve or the control of the steam is controlled by this, tinatawag natin tong solenoid valve. So, yung solenoid valve na yan yung mag-on-off para papasok or matitigil niya yung flow ng steam. Okay? So, papasok yung steam niya dyan at saka, pag nandito na sa loob ng tangke, painitin niya yung fuel oil natin. So, ito yung basic concept and then paikot-ikot lang yan. Okay? So, para mas maintindihan pa natin to, let us take a look at the temperature at saka time diagram. So, ito yung temperature natin dito. So, yung temperature, yung sa anong axis to? X or Y? Okay? I-review natin dun sa Cartesian coordinate system natin, di ba? Sa Cartesian coordinate system natin, dalawa yan. We have the x-axis and then the y-axis. Okay? So in this particular case here, yung vertical line na yan yung tawag natin, that is our y-axis. So y-axis, yung label ng y-axis natin dito is yung temperature. And then yung x-axis natin dito, this is with respect to time. Okay? And then take note, we have two values here. We have three values. We have 61 degrees centigrade, you have the 60 degrees centigrade, and you have the 59 degrees centigrade. So, according dun sa previous example natin kanina, the 60 degrees centigrade, yan yung tinatawag nating set point. Okay? Set point natin, so basically, yung thermostat natin nakaset dun sa 60 degrees. So, we want to control the temperature of the fuel and maintain it in 60 degrees centigrade. Okay? Yan. And then yung, so, dalawang condition natin. You have the 60 man yan, and then we have the 61 at saka yung 59. So, yung 61 dito, yung 61 degrees centigrade, okay? Ang gagawin ng balbula natin, yung sa control element natin, yung sa solenoid valve, i-off niya. So, ibig sabihin, pag naka-off na yung valve natin, hindi na makapasok yung steam. So, pag hindi na makapasok yung steam, hindi na makakainit yung, makaka-produce ng heat dun sa fuel. Okay? So, the moment na i-close mo yung valve at 61 degrees centigrade, ang tawag natin dyan, that is, yung 61 degrees centigrade will serve as our upper switching point. Okay? That is our switching point. And then, yung valve naman na mag-open, i-open na yung valve niya pag yung temperature natin, nandito na siya sa 59 degrees centigrade. So, this lower portion here, ang tawag natin dyan, that is the load switching point. And then, yung distance nito, yung 59 at saka 61 degrees centigrade, ang tawag natin dyan, that is the switching differential. So, ibig sabihin ng switching differential, within this range, pag makatama na yung temperature na dyan, for example, in this particular case here, pag tumama na yung temperature mo at 59 degrees centigrade, yung valve niya, i-open niya so that the steam can enter to the fuel para painitin niya yung fuel. Okay? And then, pag increase na yung temperature, pag umabot na yun dun sa 61 degrees centigrade, patayin niya na yung valve. So, pag pinatay niya na yung valve, nakaabot na siya sa tinatawag nating upper switching point. So, yung distance between 61 degrees and 59 degrees centigrade, which is 2 degrees centigrade, ang tawag natin yan, that is the switching differential. Okay? So, para mas maintindihan pa natin, let's put some values here. Okay? So, yung brown na to, yung brown na yan, yung parang square wave, hindi parang, that is a square wave, di ba? Hindi yan sinusoidal wave. That is a square wave. So, ang ibig sabihin lang dyan, pag nasa dito siya sa 59 degrees, this indicates na naka-open yung valve natin. And then, pag nasa taas na siya, naka-close yung valve natin. This will help us in our analysis later on. Okay? So, take note guys, the moment na i-open mo yung valve, di ba? Pag naka-open yung valvula mo, yung steam niya makapasok dun sa fuel. So, ibig sabihin yan, iinit na yung fuel mo. So, to indicate yung temperature of our fuel, we call this one as the process value. Okay? Indicate natin in this red graph here. Okay? So, yung red na curve nito, ibig sabihin yan, di ba? Take note. O, sige, i-analyze na natin to section per section. So, in this portion here, nakikita natin dyan, this portion here, yung valve natin dito, naka-on or naka-off? Yung sa solenoid valve natin. In this particular case here, valve is open. Okay? So, yung valve is open natin, so valve is open, so ibig sabihin yan, yung steam natin makapasok dun sa fuel, and then, this will increase the temperature of our fuel. So, pag naka-increase na yan, increase pataas na pataas, pataas. And then, take note guys, pag yung temperature mo dyan, makaabot na siya sa 61 degrees centigrade, automatic nandito ka na sa next stage. So, yung next stage mo ngayon, ang gagawin ng valvula mo, 61 degrees centigrade na to. So, kailangan mo tong patayin. So, pinatay niya yung valve. So, ibig sabihin, yung temperature niya, yung steam niya, hindi na makadaloy dun sa fuel. Okay? So, patay na yung solenoid valve. However guys, take note, may residue ka pa, may residual heat ka pa na naiwan doon. So, ibig sabihin, hindi man yan automatic na, hindi man yan kabayo na pag sinabi mong, so titigil na, tatakbo. Hindi yan automatic na ganyan. It takes time. It takes time to adjust. So, in this particular case here, yung pag sinabi mo, pag yung temperature mo, nakaabot na ng 61 degrees centigrade, due to the residual heat in the system, i-increase pa yan, mag-i-increase pa. Nag-i-increase pa, di ba? Nag-overshoot siya. So, yung overshoot niya na ngayon, increase ba yan? And then, to the point na, pag na-reach na yung peak, okay, bababa na yan. Kasi pinatay mo na yung steam na nag-supply sa kanya. So, pababa na yan, pababa ng pababa. Okay? And then, pag yung pababa mo naman, pababa, pag nakaabot na siya ng 59 degrees centigrade, automatic, nandito ka na sa third stage. So, yung third stage mo na ngayon, nasa 59 degrees centigrade ka na. So, ang gagawin ng valve mo, kailangan niya namang i-on. So, pag on ng valve mo ngayon, hindi pa yan automatic, di ba? Hindi ka man always makarecover. Parang love life din yan, di ba? So, pag na-broken hearted ka, bababa pa yung life mo, di ba? Hindi ka pa makaka-move on agad. So, parang ganito din yung system natin dito. So, in this particular case here, pag nakaabot na siya ng 59 degrees centigrade, so, nag-on na yung valvula natin. Pag on ng valve natin, hindi pa yan automatic, naiinit na yan. It takes time again para painitin ang isang bagay. Hindi man yan automatic, di ba? Pag magpainit ka ng isang bagay, hinahinay lang yan, di ba? Hindi yan automatic na init agad, di ba? So in this particular case here, pag pinainit mo yung isang bagay, it takes time para makainit yon yung fuel natin, and then nag-steady na yan, and then paikot-ikot na yan, paulit-ulit na yan. So there is an overshoot in this particular case here. So yung distance niyan, yung tawag natin dyan sa wave na ito, yung sinusoidal wave, yung pinakataas na dyan, ang tawag natin yan, the peak, di ba? The peak point of our curve. And then yung sa baba naman, yung tawag natin yung trough. Okay? And then the distance between 2 points, yung nasa dulo, nasa taas at nasa baba, ang tawag natin yan, that is the operating differential. Okay? Yan. So the major, although this on-off control is very simple, yun yung advantage niya. One of the disadvantages of this type of control action is the operating differential. Itong operating differential, yung distance nito might fall outside the tolerance required by the process. So, ibig sabihin yan, baka yung process mo is nandito lang banda, and then baka yung tolerance ba, yung parang same dun sa resistance natin, yung sa resistance plus minus %. So, yung operating value niya, nasa ganyan lang. Baka lang, so lalampas siya. So, there is a chance na lalampas siya sa tolerance level na makakasira dun sa system natin. For example, yung sa mga main engine fuel temperature natin, which requires really precise na control. So in this particular case here, hindi natin to pwede gamitin yung on-off control system. That is why we have to proceed to other type of system, yung tinatawag nating proportional control. Okay? And then the advantage of this type of system is it is very simple and it is very cheap. Okay? Which is, kung yung concern ng design ng system mo, kung hindi naman importante, very important yung accuracy of the control. Okay? So, pwede mo itong gamitin. Okay? So, next is, we have the sequential control. I believe, if you already watched the previous video, yung sequential control natin, na-discuss na natin to, but i-recap lang natin para mabuo yung discussion of our control system. So, yung sequential control natin is an event-based process in which one event flows another until the process sequence is complete. So, step by step. Hindi siya pwede mag-overlap. I-follow niya talaga yung sequence. Kaya nga tinawag siyang sequential control. So, dun sa example natin, ito yung sequencer natin used for liquid mixing. So, nagmi-mix tayo ng dalawang liquid. Okay, this one is, I took this picture or this example in the book of William Dunn sa process control. So, in this particular case here, ang goal lang natin, i-mix natin yung dalawang liquid na nasa tank A and nasa tank B. Okay? And then, yung labas niya nandito sa valve F. So, yung sequence nito is, for example, yung sensor natin dyan, yung level sensor natin, magsisend niya ngayon ng signal dun sa sequencer natin. Nasabihin niya na anong level, kung meron bang laman or wala. And then, the sequencer, pag empty yung tank natin, the sequencer will send a signal to this valve here. I-open niya yung valve A para makadalo yung liquid. Okay? And then, so, ibig sabihin, yung liquid mo papunta na dun sa tank A. And then, yung tank A mo ngayon, yung sensor niya, pag na-feel niya na, na-reach ko na ito na yung level mo. So, yung sensor mo ngayon will send signal to the sequencer. Yung sequencer mo, nasabihin niya na, uy, puno na yung tank ko, puno na ako. So, therefore, the sequencer again will send signal to this valve here, valve A, na sabihin niya na, oy, tumigil ka na kasi puno na yung tangke. Okay? And then, ulit lang, the same procedure dun sa tank B natin. So, yung sensor natin, will send signal to the sequencer na empty siya, and then the sequencer will send signal to that valve there, yung valve B natin na i-open niya. Open mo yung valve, and then yung liquid natin makadaloy na dun sa tank B. And then, pag na-fill niya na, napuno na yung tank B niya, so yung sensor natin will send signal to the sequencer, okay? And then, yung sequencer natin will send signal to that valve there na patayin niya na yan kasi puno na yung valve B natin. And then, of course, puno naman, so ang gagawin na yan ni sequencer will send signal to these two valves here, yung valve C at saka valve D. Nasabi niya, open ma, i-open mo na. So, yung fluid natin will go to tank A, papunta dun sa tank C. Tank B, papunta dun sa tank C. So, yung fluid natin, nandun na sa tank C. And then, yung dalawang sensors natin dyan, will send signal ngayon, papunta dun sa sequencer, na sabihin niya na, puno na, naubos na, na-empty na yung lahat ng liquid ko, napunta na dun sa tank C. So, therefore, ang gagawin ngayon ni sequencer, okay, given a certain amount of time, it will send signal to the mixer. Yung mixer natin ngayon is a motor, so aandar na yan for a certain duration, depende dun sa required ng system mo, iikot-iikot na yan, and then, pagkatapos yan, the sequencer will send signal to the valve F na open ka na palabas. So in this particular example here, the point of this particular example is there is a required system, a sequence na dapat sundin yung process mo. Pag may nabulilyaso sa particular system na yan, hihinto yung buong process and then kailangan mong i-troubleshoot. Okay? So this one is an example of a sequence control system. Okay? So dito naman tayo sa tinatawag nating proportional na control. So kanina, na-discuss natin na tatlo yan. We have the proportional action, we have the integral action, at saka yung tinatawag nating derivative action. Okay? So, yung proportional action natin is the simplest and the most commonly encountered of all the continuous control modes. So, ito yung pinakamadali. And then, in this type of action, according to this one, the controller produces an output signal which is proportional to the error. Okay? So, anong ibig sabihin? Okay, let's say, for example, yung temperature mo, yung error in your signal, for example, yung set point mo ngayon is, let's say, same kanina, nasa 50 degrees centigrade. Okay? So, 50 degrees centigrade and then, 60 degrees centigrade, and then, yung temperature pa ng fuel mo, let's say, assuming nandun pa siya sa 60. 60 yung set point natin, let's say, nasa 50 pa. Okay? So, yung 50 at saka 60, masyadong malaki yung deviation. So, yung ginagawa ng proportional control, since malaki yung error, okay, mas malaki yung opening ng valve para mas maraming steam na makapunta doon, painitin niya. This is very similar doon sa, for example, ano ba example ng proportional? Yung maliligo ka. Yung magmaligo ka ngayon, di ba? For example, may timba ka, balde, di ba? Pag may balde ka, tapos may gripo. Okay. The moment na yung balde mo is empty pa, anong ginagawa mo sa gripo mo? Yung ginagawa mo sa gripo mo, ina-adjustan mo yung maximum, di ba? Maximum, yung full opening of your valve. Ina-adjust mo yan. Pag open na yan, and then, hinahayaan mo lang, hinahayaan, kasi malaki pa yung error. But, however, pag medyo malapit na mapuno yung balde mo, anong ginagawa mo? Hinahayaan mo lang ba? No, hindi. Ang ginagawa niya ngayon, since lumiliit na yung error mo, lumiliit na yung, malapit na mapuno yung balde mo, ang ginagawa mo, ina-adjust mo yung valvula, di ba? Ina-adjust mo, adjust. So, pag mas malapit na yung pag mas lumiit na yung error, o saka mas malapit na mapuno yung balde, ina-adjust. Pag napuno na, automatic, patay. Okay? So, yan yung concept ng proportional action. So, ibig sabihin yan, the magnitude of the error, so, hence, the greater, so mas mataas the greater the magnitude of the error, the larger is the corrective action applied. Okay? So, yan yung ibig sabihin ng proportional action. So, yung action ng controller mo is proportional to the error. Okay, so dito naman tayo sa tinatawag nating advantages at saka disadvantages of this type of control system. So, yung first advantage niya is it is relatively simple and easy to design and tune. Okay? And then it provides good stability. It responds very rapidly since pag mas malaki yung magnitude ng error mo, mas laki yung response ng system mo. So very rapidly, dynamically, it is relatively stable. And then, yung disadvantage. So dito naman tayo sa disadvantage. So the first disadvantage is offset. Okay? Yung offset niya dito, according to the definition, is this is the difference between the control point at saka yung the desired value or the set point that is referred to the offset. Ano bang offset? Okay, ganito. For example, may timbangan ka. So yung timbangan mo ngayon, nilagyan mo ng, para yung nasa makikita natin sa palengke, di ba? So for example, timbangan mo and then nilagyan mo to ng malaking load. Okay? Pag nilagyan mo ngayon ng malaking load yan, in a continuous na medyo matagal yan, so pag tinanggal mo na yung load mo, instead na yung needle mo nakatuon dun sa zero, nasa ibang value na. So naka-offset na yung value mo. Okay? So yan yung ibig sabihin ng offset natin. Okay? Yung proportional action natin, it produces offset. Next is eto, overshoot. Yung overshoot na tinutukoy nito, yung gaya nung nakita natin kanina, yung sa on-off, na lumampas siya dun sa set point mo. So in this particular case here, there is a very big chance na kung proportional control lang ang gamit mo, lalampas yung value mo. Okay? Lalampas yung value mo. For example, 60 degrees centigrade lang yung set point mo, there is a chance na lalampas yan to 62, 65, mag-overshoot yan, and then bababa in a sinusoidal wave. Okay? Yan. Okay, so we will take a look at that kind of graph dun sa simulator na natin. Ipakita ko sa inyo ano ba yung tinatawag nating overshoot. Okay? So next is yung sa integral action. Yung sa integral action naman, this is generally applied with proportional control. Kaya nga ang tawag nito is yung tinatawag nating the PI action. Okay, the proportional integral action. Okay? And then this type of action gives an output which is proportional to the time integral of the error, and it is called reset control. Okay? So tinatawag nating integral action kasi guys, if you're going to take a look at the mathematical expression of this type of action, yung sa integral natin, di ba integral calculus tayo dito? So, yung integral calculus, may integral sign talaga yan. That is integral of time. So, in this particular case here, we will not dwell too much on the mathematical kasi hindi naman, that is outside the scope of our lecture. Basta, yung point lang natin dito, okay, discuss natin yung advantage niya. The main purpose of the integral action, this is to eliminate the offset in the proportional control. Yan yung advantage niya, or yan yung trabaho niya. And then yung disadvantage niya ngayon, a higher maximum deviation, the longer response time, so mas matagal daw, and then the longer period of oscillation. Yung oscillation niya is from the transient response, example, tataas na siya, and then yan, yung parang ripple siya dun sa power supply natin. But we will take a look at that dun sa simulator natin later on or in the next lecture. Okay? And then, next is dito tayo sa tinatawag nating derivative action. So this kind of action could not be used alone in practice. So kung meron man, it is very seldom. So normally, pinapares to in a PID system or PD system. Okay? So this is because its output is only related to the rate of change of error. So ang binabasya nila ngayon yung rate of change. So take note, that is yung application sa differential calculus natin, the rate of change. Okay, so this action gives an output which is proportional to the derivative or rate of change of the error. It is known as also as the rate control. Okay, so yan. So yung PID system natin, the PID system natin is a combination of the proportional, integral, and the derivative. So this is calibrated properly para to minimize the offset, to minimize the overshoot, and then para mas madali yung response time natin. Okay, so hindi na aabot ng ilang segundo. Later on, we will take a look at this type of PID system dun sa seawater system natin and other system dun sa simulator natin. Okay? So yan. So, but before we end this lecture, let us take a look at yung mga tinatawag nating possible question and answer na lalabas dun sa quiz or exam nyo. Okay? So, let's put our thinking cap and let's get started. So, first question. So, a control system in which the control action is somehow dependent to the output is known as Letter A, closed loop control, closed loop system. B, semi-closed loop system. Letter C, open loop system. And D, none of the above. So the keyword there is, yung output daw niya is dependent, the control action is somehow dependent on the output. So therefore, there is a feedback. So kung ang output mo, mas maliit pa yung kaysa sa set point mo, pinifeed niya dun sa control. Ay, pa-increasean mo pa. So in this particular case here, this is a closed loop system. Okay? Yeah. Next question is, in a closed loop control system with a positive value of feedback gain, the overall gain of the system will be, so kung positive yun, ibig sabihin, for example, yung error mo is positive, so yung pagpasok dun sa controller mo ngayon, ibig sabihin lang yan, for example, yung set point mo is 60 degrees centigrade. And then, yung na-measure mo na temperature dun sa system mo is, let's say, 65 degrees centigrade. So therefore, mas mataas na yung error mo. So therefore, ang binibigay niya ngayon, ang sinisend niya na command dun sa controller mo is negative. Okay? Negative siya. Kaya para babaan niya yung temperature in your system. So in this particular case here, decrease. Okay? So next is, a closed loop control, a closed loop system is distinguished from open loop system by which of the following: the servo mechanism, the feedback, output pattern, at saka input pattern. So this is very obvious question. So the answer for this type is, so pag hindi mo to alam, balik ka ulit sa mga lectures. Okay? So anong answer nito? The answer is of course letter B. That is the feedback. Okay? Yung feedback from the output to your controller. Okay? So next is, in an automatic control system, which of the following element is not used? Closed loop control. So we have the error detector, the final control element, the sensor, at saka oscillator. Okay? So pag tiningnan mo yung block diagram mo, yung wala lang dito is yung oscillator. Okay? Next is, the last na ba to? So i-check natin. So automatic controllers operate on the difference between the set point and then the measured value, which is called as a offset, bias, error, feedback. So ito yung difference ng sinet mo at saka yung anong nangyayari sa system mo. So for example, in your case, yung sa fuel system natin kanina, sinet mo siya sa 60 degrees centigrade. And then, pag measure ngayon, using your sensor, nasa 61 degrees centigrade siya. So, yung difference na 61 at saka 60, which is 1 degree centigrade, ang tawag natin dyan, that is error. Okay? So, I think that's it. So, if you have some questions or clarifications, please comment down below, and I will try to answer your questions as soon as I can. So, good luck, and God bless.